So I was saying about how the whole course has been divided into four. The first part being the master data management. And I said that's the part that entails how we got the data. We connected it to Power BI. So connected to the data source. We looked into the data quality issues that are within it, So what else? So everything around how you ensured that the data set is fit for purpose, including the data governance, ownership, and all of that. That is what this master data management is about. And we are going to look at it in full, because I've not really even done the whole slide the way I should have done it. Normally, before we go into any data set, we will look at the theoretical aspect of things first, but we jumped into that data quality exercise, and that's taken us this far. And reporting, and then data modeling. Data modeling is where we are at the moment in this small report that we said we should quickly work on, and that's what we have built, the last time. And because there's need for us to go research these different terms, terminologies within data modeling, I've put a few, I've put these in the chat. Let me put it again for the purpose, for the benefit of those who just came in, so that you can see it in the chat as well. We said we need to go research what these terms are about in data modeling. I just want to look at what I've even got in my slide for them. If I have anything, I believe I do. But before then, it's actually an assignment. What have we found out is what I should be saying. Okay, I've got 10 people in class, including myself. Okay, so those keywords that are relating to data modeling are in the chat now. I need us to start unmuting and start telling us, what did you find out when you researched that, whichever one you are choosing to discuss with us. What did you find out? Did we do the assignment at all?
Yeah, I did. So I read up some of them.
Right. Okay, so let's have, you've got the floor. After you, I see Ifeoluwa has got her hand raised as well. So after you, it will be her.
Okay, so I read about foreign keys and also primary keys.
Yeah.
So the primary key is a unique identifier of every record in a table. All right, so it's more like the customer ID. They are kind of unique from the other records. Then the foreign keys, they are more like, they are used to establish a relationship between the tables. Like if there are several tables, yeah. So the foreign keys are used to establish a relationship between the various tables.
Thank you.
Mm.
Thank you very much for that. Yes, that is absolutely what it is with those two keys, the primary key and the foreign key. Okay, so if we look at this orders table, okay, we've got customer ID, order ID. Those are the two IDs I see. Okay. All right. If I go into the customers table, This is a table that gives us a list of the customers that we are dealing with in this business. Okay. And we've got their names, their emails, but we also have IDs that we generated for them. It's just like your employee number for work. Okay, the number that's been assigned to you as an employee in your organization, okay, which no one can share with you. It is very unique to you. And so on employees table in your organization's database, where they have employees table, each of those employee IDs are unique to each person. So that's employee ID, when it is on employees table, it is a primary key, okay? It is a primary key there. The same thing with this table here, which is a customer's table. We have the ID, John Smith, his ID is 1001. Sarah Ahmed, ID is 1002. Michael Lee, ID is 1003, and so on. Okay, so within this table, customer ID is a primary key because it is unique to each row, unique to each person, on this table. That makes it a primary key. But when it starts to establish its presence in another table, for example, in this case, others table. On the others table, we can see customer ID is existing. And the reason it's existing is because it's telling us that this customer with an ID of 1001 and phone number that made an order. And when they made this order, this is the ID that was generated for that particular order. On this date, what they ordered was a laptop. They ordered one laptop in London and they paid £900. Okay, and their name is John. Okay, because we are within the orders table, John with customer ID 1001 could actually place another order and appear again on another row. As we see the case with Sarah Ahmed, I believe, we have 1002 for Sarah Ahmed, and they are repeated on this row. Can you see 1002 here, 1002 here? Okay, because they are permitted on this table to appear as many times as possible. It could actually be once as well, but it is possible that it's more than once. Okay, so this customer ID becomes a foreign key on here, simply because it is a key that would help to establish a relationship between the customer's table and the orders table, as we see in our data model here. Okay, the customer ID on here, it's a primary key. On here, it's a foreign key. And while it's here, it is operating as a unique identifier. But when it is here, it is operating not as unique anymore, but as something that can be used to establish a relationship with a table that it concerns. I'm hoping that that makes sense. Okay, so thank you very much for that answer. Primary key, foreign key. The more we work with these terms as we go on, the more it would, the more we repeat as we go on, the more it would get clearer. Okay, so yeah, Ifeoluwa, you've got the floor.
Yes, good evening, everyone.
Good evening, welcome.
Yes, thank you. Okay, so I know that most of the things that you told us to research on, they are connected in one way or the other. And I didn't even know that what's the name? Power BI has this feature. I know that SQL has it, but I didn't know that Power BI has it. Okay, so to relational database, it's more like a database that stores information or data in the likes in a table in a tabular way where there are rows and there are columns. And of course, that's where the term primary key and foreign key draws out from. And like you've said, and like Mr. Victor has said as well, it's just something that's for primary key, it's something that's uniquely identifies a particular thing or a particular person. For example, our national identity card, that's our passports. Our passports. Nobody can have the same passport number. Everybody has different passport number, and so that makes it unique to a particular person.
Yeah.
And for you have said, like you have said earlier, for foreign keys as well, it's something that is transferred to another place. It means that it's something that is trying to establish a relationship between another table. Just like you have used the order to explain it better. And moving on to data modeling. Data modeling is when you are actually using you are trying to make sure that a data is properly structured. For example, for a company that has businesses in different states, they'll be trying to ensure that all their sales are coming in into a particular database or a particular place. So they are trying to store their data in a particular point or at a particular unit. So what they are trying to do at that moment is they are trying to do their data modeling. They are trying to structure their data into a single point. So yeah, I think that's
Thank you. Thank you. Thank you very much. That's really, I love the way that you have brought all of them, almost all of them together. I love the fact that you saw the interconnectivity, between them. I'm looking at my slide to see if I've got some of these terms there. I've got a few, but not the way that I really want. Let's see what chart tells us about relational database. Okay, let's see the explanation that chart is going to give us about relational database. Okay, so like you said, storing of data in tables that are connected. Okay, they are connected. That's where the word relational comes from. Okay, the tables, they've got to have connections between each other, just like we see in our Power BI that we're building. We see there's relationship between customers and orders, between products and orders, between location and orders, between data and orders. So they've got to be related. If there's no relationship, then we cannot be talking about a database being relational. Okay. So it says it's a way of storing data in tables that are connected to each other. Think of it like Excel, but smarter and more structured, exactly as you mentioned as well, that about how well it is structured. Okay. So a relational database organizes data into tables, like you have in your Excel sheets, rows and columns. The rows are the records and the columns are the fields or the attributes. Let's see how that works here. So if we look at this in the tabular view or table view, okay, we're looking at each of these are columns or attributes or field. You can call it column, you can call it a field. Customer ID is one field, phone is another field or attribute. Each of the row is a record. If you look at this on a row, that's a complete record of an order that is made by a customer. The same goes for the other tables as well, okay? Each of these columns or fields or attributes, that's what they are. But if you look at things on a row level, you're looking at a complete record, okay? So that's a record for John Smith. The second one, a full record for Sarah Ahmed, and so on. Okay, these terms are important for us to understand, because the more you understand it, the more you would be able to use it in an interview correctly and confidently, when you talk, it would enrich your vocabulary as you talk. Okay. Real life each table holds a specific type of data, and tables are linked using keys, as we have seen with the issue of the primary keys and the foreign keys that we have. Okay. So imagine a school database. This is another example to drive the point home very well for us. Student ID 1, their name is John, and they are aged 15. Student ID 2, their name is Mary, and they are aged 14. Now, this is the course that they are offered. On the course where the courses are recorded, course ID 101 is maths. Course ID 102 is English. You see, the first one was the students table where student records are kept. The second one is the courses table where courses that are offered records are kept. Enrollment table, record where they keep students enrolled, okay? Student ID 1, John, course ID 101 is enrolled for this course. Mary, which is the student ID 2, is enrolled for this 102, okay? Can you now see that all three tables are related, or the first two tables they've got relationship with this enrollment table, because we can see the student ID as well as the course ID. So those two tables, students table and course table, they have a relationship with the enrollment table. That's a relational database of all of them together. If you look at all of them together as a database, all three are a relational database. Already we can see that on the enrollment table, real life, student ID 1 can be enrolled for more than one course. There's no rule to say that a student that's enrolled for course 101 cannot also be enrolled for 102. So they can be each student can be repeated here, and each of the courses can be repeated here as well, because different students are doing as many courses as possible. You see, so concepts of, I only ask for relational database to be explained, but do you see how chat is bringing all our terms in? Because like Sister Ifeoluwa was explaining the relationship between all these. When you're talking data modeling, you will be talking relational database, you'll be talking about the primary key, the foreign key, and the type of relationships, that they have, within themselves, okay? So the key concepts in those three tables now, a unique identifier for each row. For the student ID, we see that on the, let me go back up a bit. On here, student ID is the unique identifier. Anytime you mention ID 1, you are talking about John. 2, you are talking about Mary. And on this table, this 1 and 2 and whichever number cannot be repeated. That's what makes them unique identifiers on this table. Same for course. On the courses table, maths is not going to be repeated. 101 for maths, 102 for English, 103 for another course, okay? So that makes course ID a unique identifier. So a primary key on this table and a primary key student ID is on this table as well. But when we get to enrollment table, where these students can be enrolled for courses, student ID 1 can enroll for 10 of the courses that are offered in a place. Student ID 2 can enroll for more than one, okay? So that makes each of these IDs no longer primary, because they can be repeated, they can be duplicated here. So student ID here becomes a foreign key, because it's just now for relationship purpose, to use it to relate to another table, the student table. And the same goes for the course ID. It is also a foreign key here, because it is, 1, it is repeated, or it can't be repeated. 2, it's used to form a relationship with the courses table. Okay, so that's how that works. Okay, let's see. It says primary key, a unique identifier for each row, e.g. Student ID. foreign key, a field that links one table to another, e.g. student ID in enrollment. Can you see the same student ID that is a primary key here on student table? That has to be stated that student ID is primary key on student table. It becomes a foreign key on enrollment table because it is used as a link to form relationships. And because, again, it can be duplicated, it is no longer necessary for it to be unique here. Okay. And the different types of relationship that we form, one-to-one, one-to-many, many-to-many. I love the fact that Power BI explains this. While we are on that, let me show it in Power BI, the different types of relationships. Although I can only show one, while I'm hovering on this relationship, if I right click and go into properties, we will see, okay, what's this telling us? Let me hide this. Okay, so it says edit relationship. Well, normally you would open this up if you were going to edit something, okay? From table, other table, which is the table in the middle, is telling us or highlighting the column where the two columns where the relationships are forming, customer ID and customer ID. And for the second table, the name of the table is customers table. You can see the rest of the tables are listed there, okay? Cardinality now, that is the type of relationship. That's the meaning of cardinality. It's telling us that the cardinality, that is the type of relationship that is formed here, is many to one. Many being the relationship is flowing from other table. This is called many because customer ID can appear many times here. Okay, a customer can make orders, place orders as many times as possible, and it will be recorded here as many times as they do. That's why this here is the many table for this relationship, many to one. Whereas on customers table, we are expecting each of the customers to appear just once. On their IDs are supposed to appear just once. Okay, that is why it's a many to one. Some other times you would have one-to-one. That is, the customer ID is only appearing just once all through here, and same goes for here. That's what the data, that's what Power BI found. Okay, that's not your most ideal situation, especially if you are forming this kind of star schema that we formed, but it is possible for it to happen. Okay, if all the customers here had placed orders just once, and no one's repeated, it will tell you that the relationship is just one-to-one, I believe, okay? Or it could be one-to-many, okay? Many-to-one and one-to-many, it is just the direction of flow that is different now, but invariably, it is the same type of relationship. If you are forming many-to-one or one-to-many, okay? That's normally the type of relationship that we aim to form, ideally. Sometimes a lot of data issues may not let that happen, but it is the ideal kind of relationship that you want to aim for. And then we have many to many, which we don't normally aim for, all things being equal. But with data, a lot happens and that can happen, okay? But your aspiration for forming relationship, what you should aspire for is many to one or one to many, okay? That is, I'm joining a fact table to a dimension table, basically, okay? Cross-filter direction. If we look at, let me cancel this. Let me show you this first. Cross-filter direction, either single or both. Okay, it's just telling us that the direction of the arrow is saying that this is flowing in this direction, okay? If you want the flow to be both ways, then you would have clicked on both. But for one-to-many or many-to-one, one directional or single direction of flow is all right to choose, I may look for more videos, YouTube videos that would explain a lot in data modeling. I think I have one in mind. I'll drop it on the platform so that we would have you hear these things from another teacher's perspective, and then that will drive it home more for you. The more you hear it from different perspectives, the better for learning purpose. Okay, and that's what chat is telling us, why relational? Because tables are related to each other. They are not isolated. And it goes on to say more, but the long and short of what we needed, what we need to learn is what about relational database is what we have seen, so far. I wanted to get to the chart, yes. Very quickly, attendance is link has been dropped. Okay, that's fine. Grace, that's fine. Attendance sheet link has been dropped. Let's try and mark our attendance before we leave. So we've seen what primary keys are, what foreign keys are, unique identifiers, which are same as primary keys. It is uniquely identifying something. Okay. The concept of fact table and dimension table, we haven't seen yet. So let's see if we can quickly explain that. And then star schema and snowflake. Let's see how we can quickly get that going. What are fact tables and what are dimension tables very quickly? Okay. Let me see. I've got a call that I can't pick just yet. Let me see what I've got here. Or should I just approach chat to explain it to us? Okay. Explain the concept of facts and dimension table in data modeling. Okay, let's see how chat would put it. Okay, says great question. This is called to Power BI data and data modeling. And once you get it, everything starts to click. Okay, the big idea, simple first. In data modeling, fact table equals what happened, the measurable event. If we go into our table, now we are saying orders table is a fact table. Most of the time, your fact table is the many side. It is where the events of that organization is recorded. Okay. In this case, it is event is we are selling, so people are placing orders. So orders being placed is events. Okay. And that can happen as many times as possible with one customer. Okay, that's why it is the many side of the relationship. But why is it fact table? Okay, so if we look at orders table here, okay, and then we look at what chart is saying fact table equals what happened, the measurable events. Okay, now from our Power BI table, what is measurable here? We can measure price and we can measure quantities. We can count the rest as well, but ideally you are measuring how much we made, how many products did we sell, okay? And that's why this is your fact table. The rest are dimensions because customers table is only giving us information about your customers. So it's another name for dimension table is lookup table. Okay, this is where I can quickly look up, okay, which customer is customer 100009. Okay, if I quickly come here, I can easily get, okay, it is Deborah and Ifoshe, okay, and okay, I have the information on them. This is where that is stored. It's a lookup table. It gives information. It is for information purpose only. Those are dimension tables. There's nothing we are measuring there. Okay, they are our database where we store our information. Okay, for customers, for our customers, any new customer comes, we add their information to the next row. Another one, new one joins, we add their information to the next row. So it's a database just for looking up or collecting our customer information. Okay, so that's why it's a dimension. It tells us the who about our business. The who is the customers. Okay, and then the products table. It's just giving us a list of the products that we sell. Ideally, the product table will have product ID as well. Each of these products will have their unique IDs, ideally, as well. Okay, so we can only come here and look up, okay, which products do we normally sell that we have sold so far? Laptop, monitor, key, mouse. Okay, fine. Okay, it doesn't tell us how much we have made. It doesn't tell us how much we have sold. All information around measurables is on others table, because that is where, I don't want to mention money, but that's where sales happen, because not all businesses are about money. Some businesses would be not in monetary terms, like NHS database is about patients information, like maybe airports, it would be about the number of airlines, would be about the number of passengers, or any transportation company at all, so those are not measured in money terms. Okay, but events are being recorded. Okay, a certain customer has flown with us 5 times this year alone. There would be a table that records maybe flights, outbounds or inbounds flights or whatever. However, I've not seen their database before. I wouldn't know, but it would definitely be recorded as that. Okay, so in that case, you are still measuring how many passengers, how many flights did we process in the last 1 month? Okay, you will still measure stuff like that, but those are not measured in money terms, but we are still measuring something. So that doesn't make them any less a fact table, okay, than this one. Okay, so very quickly, I don't want us to exit or go too long into the hour because of our 9 o'clock. Okay, so fact table, the numbers table. Okay, there are other information on the fact table as well, obviously, but we are majorly concerned about the numbers that we can measure on the fact table. So it is the quantitative data, okay, the data that gives us our KPIs, the cost, the profits, the quantity, Okay, so the key points to your fact table, it contains metrics. It's usually large, many rows because of repetition that could happen, like a customer placing orders in one day could place like 10 orders and nothing would happen. Okay, links to dimension tables using keys. It would always link to the dimension table using keys, like we see again in this case. Our fact table here, which is the others table, is linked to all these dimensions using key. Customer ID is a key. In this case, we used product name as key. Location, we use city as key here, and we use the others date here as the key. Okay, so that's what a fact table is about. But dimension table is the description table, the qualitative, we said about different types of data, quantitative and qualitative. Quantitative is the facts table, that's what the fact table gave us, or we derive more from fact table. Qualitative sites now, descriptives, okay? Like the customer is a descriptive, the location is a descriptive, the date is a descriptive. It gives context. Okay, so It's giving context to the numbers that you are generating, okay? Without the dimensions, or without the customers, without the products, without the locations, these numbers that are generated here, all these prices and quantities will be meaningless. They will be meaningless because there's no context to it. We've got to be able to put context to what we have measured in terms of, okay, we're putting context is being able to slice by products, slice by how many customers, generated how much amount for us. Okay, so that's the gist, between the fact table and dimension table. The dimensions, they are lookup tables, they give information, and fact tables, that's where you get your measurable, where the events of your business, what your business is about, your daily transactions or minutely transactions, however frequently you receive new data, that's where it is stored. Okay. And it's just, okay, why does the concept of dimension and the fact table, why does it matter? Fact table is used for measures. We will be introduced to measures, when we work with bigger data or even the small one. And dimensions are used for filters or slice, rows, columns, and visuals, okay? Like we see in our visual now, you see, we use dimensions. In this case, products, which is a dimension, you see, product is a dimension here. It's the one side of the table. And we used it to slice the total price. So we can see easily that laptop gave us the highest price, highest amount of money that came in, whereas mouse saw the highest number of quantity. That is where we start having context to these numbers, okay? It stops being just a number. It's got more meaning to it. We sold the highest amount of mouse in terms of quantity, but in terms of money, laptop is actually what gave us more, okay? How many laptops did we sell? We sold 3, and for 3 laptops, we made 2,700 in sales, not necessarily in profit, but in sales. If we had more data to tell us profit, then it starts to tell you, okay, that fine, laptop 2,700, but with those 3 laptops, what you made was just 200 pounds as profit. Okay, whereas for mouse, that looks like it's just small amount of price that it gives you. What you made from it is actually more because you were able to sell more quantity. Okay, so this is where you start to look into your data set for the purpose of generating your next action plans. Okay, next year, I want to make double the amount that I'm making this year. What should I do? What did I do? What's this data telling me that I did this year to get this far? How do I double up or triple up to make that more than that for next year, basically? Okay, so this is where you start to move with evidence. You're not just moving, you're moving strategically because you've got information right at your fingertip, okay, to tell you what you should be doing. What we have, and we have touched on this last time, star schema and snowflake. This is where we now start to look at a different type of relationship, different structure that we make, basically. After you have made your data model, the kind of structure you have built, so to say, that is what those schemas, star schema, snowflake schema, okay? If all your dimension tables can be directly linked without leaving any behind to the fact table, you have formed what we call a star schema. And that's, again, that's what we normally aim for, star schema, especially if your reports may grow over time. We are always advised to start, very simply with star schema kind of model, okay? But if your structure you have, made is starting to have branches, like another table is joining to this one because it can't join directly to this, or another table is hanging out on this. The way we have city here, let's say we have another table that's country, and country doesn't have any column that could directly link it with the other table. So it has to be linked to this, and then this links to this. So when you start having branches, other dimension tables being in relationship with your dimension tables rather than directly with the others, with the fact table. That's what we call a snowflake. Okay, two types, star schema and a snowflake. I believe I showed us images last time. We may start from star schema and snowflake tomorrow. I've got two messages here. Okay, just the attendance reminder. Thank you very much for doing that for us, Mass. Okay, I'm hoping that we got a bit of more insight into what data modeling is